Thank you very much, Pramila, and thanks very much to the you and the Brain Foundation for organizing the session. So unfortunately, my colleague, Rosie, is very sick today, so she can't be here. But again, all the work I'll be presenting has been done in close collaboration with her. We need to make some disclosures. Several of us on this group have pending or approved patents for the use of FMT and probiotics for a variety of conditions. We've also received research funding and consultancies from Finch Therapeutics. I need to point out that microbiota transplant is an investigational treatment, not approved by the FDA for autism. And also, 3 of us are part owners of Autism Diagnostics, which is developing metabolomics tests for diagnosing and treating autism, and we have several patents pending in this area. So to begin with, 9 years ago, I published a paper which showed that there was a very strong correlation between GI severity. So the left-hand axis is the gastrointestinal severity score based on 6 different symptoms. And on the bottom is the ATEC, the Autism Treatment Evaluation Checklist, which is a broad evaluation of different autism and comorbid symptoms. And what we found is a strong correlation, R of about 0.6, and also very strong differences for each of the 4 subscales of the ATEC: language, social interaction, cognition, and behavior. And so imagine that if you look at this upper right end, where children have high GI severity and high autism severity, the question is, if we can treat those GI symptoms, can we reduce then their autism symptoms as well, going from scores of 120 maybe down to scores of 20. So that's our hope, is that by treating the GI symptoms, we may be able to reduce autism symptoms to some extent. There was a powerful study in 2000 that really motivated our work in this area, done by Sandler and Sid Feingold, Ellen Bolte, and others. And giving vancomycin, which is a strong antibiotic, giving it orally, and the reason for giving it orally is it's very low absorption, so its action is primarily just in the GI tract. They found a large improvement in GI symptoms over the course of 8 weeks, but also surprisingly a large improvement in autism symptoms. So this is a rating scale going from 0 to 6, showing that most of the children had a substantial improvement, some quite dramatic improvement in autism symptoms. Sadly, when they stopped treatment, within just a few weeks, those gains in GI symptoms and gains in autism symptoms were largely lost, even though a few of the children did receive some standard probiotics. So this is a major clue that gut bacteria are very important in children with autism, but also that just killing them temporarily is not enough, that what we need to do is go beyond that and try to find a way to change them long term. And so if we think about the microbiome, it's really quite unique to each individual. After the age of several years, it's generally relatively stable throughout life, unless you have a major interaction, antibiotics, or infection. It's affected by a variety of internal, external factors. Diet, certainly a very major role. It's altered in disease, and it's strongly affected by the residence time. So as your gut bacteria and as your food or stool passes through the GI tract, that's going to affect the type of gut bacteria that are present. It's important to realize that the microbiome has of order 100 times as many genes as the human body, and it also has a very high metabolic activity. And so even though it's a relatively small part of the body, a few pounds, it's very, very metabolically active. And so therefore, it seems very plausible it could have a large effect on autism symptoms. So one way of thinking it is at the gene level, we're 1% human, 99% microbe. The microbe impacts many different aspects of health, clearly obesity, heart disease, autism, which we'll focus on, and a variety of other conditions. And potentially, improvements in the microbiome could improve metabolism, GI health, behavior, mood, obesity, drug activity, etc. So there's a lot of potential for improvements in the microbiome. As previous speakers have alluded to, a number of factors have really impacted and changed human microbiome over time. The gut microbe does have major effects on metabolism that affects the host. I talked earlier about short-chain fatty acids, which can be produced by the gut bacteria, and they're very important in affecting the immune system and affecting satiation. They also are very important for providing much of the food for the cells that line the colon. Also, gut bacteria produce significant amounts of several key vitamins like biotin and vitamin K. And without those bacteria in your gut, then you would have significantly less of those key vitamins. So many, many different roles of the gut microbiome on the body, both in digesting our food, in producing key vitamins, in producing metabolites that can affect the immune system and reach the brain and liver as well. So there's been a lot of interest in the last 10 years or so, especially the last 5 years, on looking at the microbiome and autism. We heard the nice presentation by Steve Walker reviewing some of the previous data. Interest in Severity. There are half a dozen studies showing elevated levels of Clostridium, not C. diff, but some of its nasty cousins, especially C. bolti, named after a mother of a child with autism, because it was found primarily in children with autism, but also some other nasty Clostridia species. And also, a big part of our focus has been looking at the beneficial bacteria, and we suspect that it's a lack of the beneficial bacteria, bifidobacteria, lactobacillus, Prevotella, and lower diversity that leads to the problem. So a simple analogy I like to give is if you have a garden filled with weeds, if you have gut bacteria filled with a variety of pathogens, you can pull all those weeds, you can remove those pathogens, but what's going to happen? If you don't do anything, those weeds are just going to regrow in your garden. Those pathogens will just return. So we need to not just pull the weeds, but also to replant with healthy bacteria. So there's, again, a lot of controversy in the community as to which bacteria are important and which ones are different in autism. When we're dealing with thousands of bacteria, we just need much larger studies, and we're going to see differences in different populations based on the foods that they're eating and other factors. So one study that we did, and we've replicated this in a couple other studies, is looking at the microbial diversity. So in Rosie's lab, she measured the microbiome diversity in two different ways. One is using the Chow-1 estimate that basically counts the number of species present. And so if we look at the 97% level, which is approximately the species level, the blue are the children who are neurotypical, the red are the children with autism. This is on a log scale, so the differences may not seem very large, but they are quite large. And so what we see is that typical children have a higher diversity. Children with autism missing of order 25% of the species that are normally present. And we see that also when we look at higher levels, looking at family or genus level. Also, we can look at the phylogenetic index, which is a measure of the genetic diversity. And again, we see that children with autism are missing many of the genes that are present in the microbiome of healthy children with autism. So they have less metabolic capability, and are clearly just another major indication that they're missing many key gut bacteria. In particular, when we deal with false discovery rates, we saw that one category of bacteria in particular, Prevotella, was quite different in children with autism. So this axis shows many different Prevotella species, and we see that this group on the left are children with autism. We see a few children with autism do have a few of these Prevotella species, more common in the typically developing children here on the right. But typically developing children often have many of these other species of Prevotella that we did not see in any of the typically developing children. Also, what's interesting to note is the scale is the severity of their GI symptoms, ranging from minimal GI to major GI symptoms. We said it didn't matter. The children with autism had minimal GI symptoms or major GI symptoms. They were missing these Prevotella, and they generally had lower diversity of gut bacteria. So if you're missing hundreds of species of gut bacteria, the question is, how can we replant those? And so we need to digress a moment to look at the research on fecal microbiota transplant for Clostridium difficile. C. diff infections are very nasty infections that cause life-threatening diarrhea in about 500,000 Americans each year, and it kills about 29,000 Americans a year. They can be treated with antibiotics, but it often returns afterwards. And so in cases of recurrent C. diff, so it's been treated with antibiotics and then comes back, fecal microbiota transplant has been used. So taking the human stool, roughly half of which is live gut bacteria, and putting that into people who have C. diff infections, typically by endoscopy, but it can be done through a rectal enema, also can be done through a nasal gastric tube into the stomach. Just one dose or 2 doses will generally cure C. diff in 2 to 3 days with about a 90% plus success rate, and essentially never returns, unlike with antibiotics. FMT is now used by hundreds of hospitals in the US to treat over 50,000 patients with C. diff, but it's not yet been approved by the FDA. So it's a very interesting case where it's been widely used, and the FDA has allowed it to be widely used because it's so effective, but it has not yet gone through the formal FDA process. So it's not approved for C. diff, it's simply allowed for it. Our collaborator, Thomas Brody, a gastroenterologist in Australia, has used FMT for treating over 17,000 people, and he used it to treat 9 children with autism. Unlike patients with life-threatening C. diff, where 1 to 2 doses is sufficient, Dr. Brody found that children with autism were much harder to treat than people with life-threatening C. diff. He had to treat them every day for 3 months to slowly, gradually shift their microbiome for what was apparently a very stable but unhealthy microbiome to a healthy one. And this led to eventual improvements in GI symptoms, and also he was surprised to see some substantial improvements in autism symptoms. So his experience led us to go on and develop our own microbiota transfer protocol. And we call this a different name instead of just fecal transplant, because C. diff is 1 dose, 1 time. And that's not nearly enough for most children with autism. So we use 2 weeks of oral vancomycin to clear out pathogenic bacteria, 1 day of fasting and bowel cleanse to remove remaining bacteria, as well as to remove the vancomycin, and then high dose microbiota, either given orally or rectally, and then 7 to 8 weeks of low dose microbiota, but we also gave Prilosec to reduce the stomach acid, because otherwise that would kill off most of the bacteria that we're giving. The microbiota are from highly purified stool samples from healthy, very carefully screened donors. They're roughly over 99% bacteria. So it's like giving a super probiotic with 1,000 plus species of bacteria. And so using this approach, we found that there were good improvements at the end of treatment. So if we look here at GI symptoms at the start of before treatment, this is baseline. After treatment, by the end of 10 weeks, we saw a good benefit. We then waited 8 weeks, and unlike the Vanco study where the GI benefits were lost, the GI benefits were stable at 8 weeks. So we were thrilled. We published the paper, and then a year later, several families came up to us and said, Professor Adams, my son's doing better than ever. So then we went ahead and did a 2-year follow-up with all of the participants. It's very unusual to do a 2-year follow-up. This is one of the first ones that's been done for FMT. And what we found is that 2 years later, most of those GI benefits remained. There's one child who had had an antibiotic and lost most of the benefits, but most of the GI benefits had remained. So that was very exciting. And when we look at the subscales, we saw improvements in abdominal pain. We saw improvements in diarrhea, improvements in constipation. So in the major subscales where we saw problems, there were improvements across the board. It's very interesting that a treatment could treat both diarrhea and constipation, which are one could think of as opposite symptoms. But more importantly, we were very excited to see great improvements in the childhood autism rating scale. So at the start of the study, the children were generally in the severe range. So if you're above this pink bar, that's the severe range of autism. This bottom pink bar is the cutoff between not getting a diagnosis for autism and getting a diagnosis for mild to moderate. At the end of treatment, there was some improvement. Again, this is an open label study, so there's certainly some placebo effect. But the CARS is rated by a professional evaluator, and most studies of CARS show fairly minimal placebo effect. 8 weeks later, benefits were still stable. What really surprised us is that 2 years later, even more of the children had improved. So now roughly 40% were below the cutoff for autism diagnosis, and only a few percent, we went from roughly 80% who were severe to only of order 20% who were in the severe range. So great improvements in symptoms, but again, open labels, we have to be cautious. When we look at other scales, we look at aberrant behavior. So we saw statistically significant improvements in irritability, in lethargy or social withdrawal, in stereotypies, in hyperactivity and inappropriate speech. And using the SRS, the social responsiveness scale, we saw improvements in key areas related to social awareness, social cognition, social communication, social motivation, and social mannerisms. So just seeing improvements across the board in most, not all, but most of the participants. Then Rosie's group looked at the microbial diversity. And so the red is the dotted line for the one of our donors. The green is the dotted line, is a median diversity of typical children. So we see children with autism started out with lower diversity. And then by week 10, that diversity had normalized, which was great to see. And then 18 weeks after treatment, we saw even more improvement. We saw it was still stable. And then 2 years later, what was very surprising is the diversity was even higher than in the neurotypical children, approaching that of our maintenance donor, who was a very healthy person with a very high microbiota diversity. And so very intriguing that these children had gone on to achieve a very high diversity, even higher than they had at the end of treatment, suggesting this treatment is going to be stable for much more than just 2 years. Also, if we look at the difference between the child with autism and their donor, so this is at baseline, there's a certain difference from their donor. After treatment, they're much more similar to the donor, as they should be, because their gut has been cleared out and we put in their donor's microbiota. At week 10, it's still fairly similar. Week 18, still fairly more similar to the donor. But at the 2-year follow-up, it's now no longer particularly similar to the donor. Rather, it's been personalized for each person based on their diet and perhaps other factors. So they have a high diversity, but it's now more uniquely their own 2 years later. We saw after we do false discovery rate, several significant changes in the microbiota. We saw that bifidobacteria increased roughly 4-fold. So that was very exciting to see. Prevotella, we also saw major increases, roughly 80-fold. That was very low, nearly non-existent or unmeasurable in most of the children with autism. And T-cell Vibrio, which it's some debate as to whether or not it's beneficial. All we can say is that we did see a significant increase in that as well. So overall, we can say that the microbiome changed, but each individual had their own new personal microbiome. The GI improvements lasted for most, but not all participants. There was an initial reduction that was substantial, and most of that remained at 2 years. The autism symptoms just seemed to, family after family said, just a slow, steady improvement after treatment in most, but not all participants. 24% initial reduction in CARS, autism symptoms, but an even greater 47% reduction at 2 years. But again, open label study, some placebo effect. So we're now working on randomized studies. In the interest of time, I'm going to just mention here briefly, we also have done some metabolomics work. We identified 11 metabolites that were very different in children with autism in their plasma. So the red are the typically developing children, and the red squares, and the red circles over here are the children with autism at baseline. At week 3 are the blue dots. You can see quite a few children now have snuck over to this area. And now what we see, excuse me, I have that backwards, I apologize. The green dots here are the typically developing children. The red dots are the children with autism at baseline. And what we see is that at week 3, the blue dots are now mostly over here clustered with the typical children. And at week 10, the green dots are almost all clustered closer together with the typical children. Another way is to show the average distance of the metabolites, and we see at baseline versus week 3 versus week 10. The metabolites on average are becoming much closer to that of the typical children as measured in the blood. So the metabolites category, the metabolic categories that changed significantly were amino acid metabolism, certain cofactors and vitamins, lipid metabolism, nucleotide metabolism, and xenobiotics. We're now working on a phase 2 study of adults with autism, funded by the Department of Defense and 1,000+ donors, including, we want to thank the Brain Foundation for their support of this study. This is basically going to be a randomized, double-blind, placebo-controlled study. Half the group receives the vanco, half placebo, and then the bowel cleanse, then high dose microbiota transplant, and then maintenance. And then the treatment group continues maintenance, and the placebo group is then switched to microbiota transplant without vanco, because we're wondering whether or not vanco is needed. And so currently we're working in a variety of areas. Dr. Rosa is working on metagenomic analysis, whole gene metagenomics, so we can look much deeper at the metabolism and the species. Also, we're doing a study, as I mentioned, with Dr. Rich Fry and now Steve Walker on our study of adults. We've treated now about 38 adults. We have another 46 to go. And we're just starting a new child study, randomized double-blind placebo-controlled study for 50 children with autism. And the basic goal is to prove efficacy and see if the vancomycin pre-treatment is needed, to search for biomarkers, and to try to really understand what are the mechanisms through which FMT is apparently having some major effects. We also have an opening, we've also just started a new national probiotic treatment study. And so this involves a collaboration with Sun Genomics, where we do detailed analysis of the microbiome and then provide customized probiotics based on that for each person, open to both children and adults in the US. And then we want to thank the many different groups and the families who have participated in our study, many collaborators, and again, thanking the Brain Foundation for giving us a chance to present this work and for supporting it financially. So we'll see if there's time for a question or two.
I will ask some questions from the audience. Are the species being used in ASD, MTT different from what's used in CDI?
These are the same capsules that are also being used for some studies of C. diff. So we basically use the same screening process to collect stool samples from very healthy, carefully screened donors. But depending on the donor, each donor will have their own individual microbiome. but the general process, the general screening is the same.
You mentioned how one of the study participants lost their gains due to subsequent antibiotic use. Since it is hard to expect zero or low antibiotic use over the course of life, how stable do you expect the post-FMT improvements to be?
It's a great question. We had one family who right at the end of treatment then took a round of antibiotics due to strep throat, and they lost all of their GI benefits, and their autism benefits did not continue improving. They didn't lose them, but they didn't continue improving. So we think that was probably we think they were more vulnerable because they just finished the treatment. Our hope is that longer term, that will not be an effect, but certainly a concern. And so we can't say for sure. None of the other families that we're aware of used antibiotics, and we certainly want to caution people that although the treatment does seem to be very long lasting, antibiotics might disrupt that treatment.
Another one, this is the last one. What tests do you use for measuring bacterial diversity, and can you recommend one?
Well, certainly there are a number of groups a number of labs out there that do measure microbiome in different ways. We use two particular measures, the CHOW1 estimate that I mentioned, and the phylogenetics measurement. I don't know of a lab offhand that's using those diversity measurements, but I have to check and get back to you.